Here's a question in velocity time graph. The question says, figure 12 shows the velocity time graph of a car, which starts from res, and it's accelerated uniformly at the rate of 3 meters per second for 5 seconds. It attains a velocity which is maintained for 1 minute. The car is then brought to rest by uniform retardation after another 3 seconds. Calculate the total distance covered. In this question, I'm going to sketch the velocity time graph and input all the data. Here we have this axis here to represent the velocity. Then the diagram, that represents the slope, the acceleration, and then we have the horizontal line represent the constant or steady speed. Negative acceleration. Remember, the horizontal axis for time in second. And we have the vertical axis for speed in meters per second. The question here says the velocity time graph of the car, which starts from rest, is accelerated uniformly at the rate of 3 meters per second. Now, this is the rate here. This is the acceleration. This slope represents 3 meters per second for 5 seconds. That means that was maintained, that was accelerated for 5 seconds. That is 5 here. And the question also says it attains a velocity which is maintained for 1 minute. That means maintain the velocity for 1 minute. Maintain that at that point for 1 minute. Now 1 minute is 60. 60 plus 5 will give you 65. The axis is in second, and here we have that velocity on this axis. We note it as V naught. That will represent that the car is then brought to rest by uniform retardation after another 3 seconds. The negative slope here represent that for 3 seconds. 3 plus 65 will give you 68. 68. The question, calculate the total distance cover. The total distance cover. In velocity time graph, a distance is the area of the graph. The area of the graph, and the shape of this graph is a trapezium. So that means we use the area of a trapezium, which is half A plus B times the height. That's the area of the trapezium. And then this question here, A is the smallest. It is the smallest. 65 minus 5. That will give A is 60. B is the longest distance. Yeah, that's B is 68. And H is the height. The height, but this height, we don't know the height. We need to find V. That V is velocity at this point. That gives this constant velocity from 5 to 65. Constant. We use that by the slope of the velocity times that represent acceleration. So let's find V. I'll use this expression. Let's say there's acceleration as the slope, V2, V1, all over T2, T1. In this situation, V2 is V0, and V1, that will be 0 here, and T2 is 5, and T1 is 0. We end up having A is equals to V0 all over 5. Remember that A has been given to us 3 meters per second. That is 3 is equals to V naught all over 5. This will lead us to V naught is equals to 3 times 5. That means the speed is 15 meters per second. The speed is 15 meters per second. Now that we have the speed, which is 15 meters per second, we can go back and use this equation here to find the distance. We substitute every data given to us. D from the expression half A, B, and the height. We substitute the value. A is the value of A is 60, and B is 68. H is the height. We just calculated the height. That's V is 15. When you use your calculator, you multiply everything, that will give you 960 meters. 960 meters. That is 960 meters for that question. Thank you for watching.